Okay, class, in this lesson, we are going to learn to take a radical number and express it as a rational exponent, and then we're going to take a rational exponent and convert it into radical numbers. Okay, so let's go ahead and get started. Here's example number 1. We have a radical number, which is the square root of 4, and we're going to convert this into a rational exponent, okay? So the way we do this is to recognize that the square root of 4 is 2 times 2, okay? Now, in the lessons that we've learned earlier when we were multiplying and dividing radical numbers, we said that if you had two of these numbers underneath the radical sign, then they both can come out of the radical sign and be represented as one number, which is 2, okay? Now, what I didn't explain to you was what was really going on behind the scenes mathematically, okay? So I'm going to go ahead and slide this over to the end and show you what's going on. All right, so we're going to rewrite this square root of 2 times 2 to square root of 2 squared, okay? Now, one of the things that I did mention in a prior lesson, and I'm going to remind you, is that when we have this radical sign, okay, and we call this a square root, there's a number that's implied, but we don't write it, okay? And that number is the number 2. This is why we call this square root sign square root, right? Because the root is 2. When there's no number here, we call it a square root. But later on in this lesson, we're going to see that it's not always a square root. Okay, so now to do this particular problem, we're going to go ahead and rewrite this as a rational exponent. So this works out to 2 to the 2 divided by a blue 2 power. Okay, notice where each of these 2's come from. This 2 in the numerator comes from this power underneath this radical sign. And then this blue 2 comes from this 2 outside of the radical sign. Okay? So then if we were to continue this, we know that 2 over 2 is really equal to 1. So this becomes 2 to the 1 power, which is equal to 2. Okay? So in the past, and you may have done this with your teacher as well, they would normally take this number and tell you that it is equal to this, okay? And what they're doing is they're skipping all of this step because they didn't want to confuse you. But now we're at a level where you need to understand where these numbers are coming from, okay? So here I've spelled it out. So let's go ahead and try this next example. We have the square root of 9, okay? And so you should know that this is equivalent to the square root of 3 times 3. And this also works out to the square root, okay, square root or second root of 3 squared. And this is the same as 3 to the 2 over blue 2 power, which is the same as 3 to the 1 power, which is equal to 3. Okay, so hopefully this makes sense and you understand the pattern. Now, I used a really simple example, but as you might surmise, or as you might sort of anticipate, we're not going to always have the same number in the numerator as we do in the denominator, like we do in this example, okay? So let's go ahead and move on to the next example. Okay, here we've got two numbers here. We've got a fifth root, okay, represented by this 5. This is a fifth root of 8 cubed, okay? So here's an example where the numerator and the denominator of the exponent will not be the same, okay? So to rewrite this, this is equal to 8 to the 3 over 5 power, okay? That is how you rewrite that. And if you take a look at the next example, this is really the same as 9 to the 4 divided by 7 power, okay? Again, this 3 in the numerator comes from this power underneath the radical sign. Same thing with this. The 4 in the numerator comes from the power underneath the radical sign. And then both the denominator, the 5, comes from the root number, as does the 7. That's the root number. Okay? Now, hopefully this pattern makes sense to you and you can kind of remember, but some of you might prefer to use a formula. Okay? So here is the formula. If we have the b root of x to the a power, that is equal to x to the a divided by b power. Okay? So if you need a formula, you can take this. And this formula works both ways, meaning you can take a radical number and convert it to a rational exponent. Okay? This is an exponent that has a rational number, which is why this is called a rational exponent. Or you could take the rational exponent and go backwards and convert it into a radical number. Okay? So we're going to use this formula and do the same exact thing with the next example. So I'm going to go ahead and take a component of the formula and paste it over here. All right? So actually, let me put it right here. Let's put it down here. Sorry. Okay, so let's go ahead and convert this rational exponent into a radical number. Okay, so if we follow this pattern, this is going to be equal to the b root. Okay, we're going to take this b. This becomes our root. So that's going to be this second root or square root of 2 to the 1 power, which is simplified to the square root of 2. Okay, now let's take a look at this next one. We're going to take 2 to the 1/3 power, and we're going to convert that into a radical number. This is going to be the third root. Notice this number goes from here to here, just like b here goes to this root number. And then we're going to keep the 2 underneath the radical sign raised to the 1 power. Okay? And that works out to the cube root of 2. And then let's do this last one. This is going to be equal to the 5th root of 3 to the 4th power. Okay? And there's nothing to rewrite there. It's the 5th root of 3 to the 4th power. All right, so hopefully that makes sense. Let's go ahead and work on the next example. Okay, we're going to convert these to a radical number. Same thing again. So 5 to the 3/5 power is really the same as the 5th root of 5 cubed. And then in the next one, 7 to the 2/9 power, that's going to be the 9th root of 7 squared. Okay, so hopefully you're getting a feel for this and understand where these numbers are coming from and how we convert them. Now let's take a look at this next one. This one's a little bit, this is going to lead us to another point I want to make. Okay, so let's go ahead and do this first. This is going to be the third root or cube root of 8 to the 1 power. Okay, now watch this. This is equal to the cube root of 2 times 2 times 2. Okay, 8 breaks down to 2 times 2 times 2. That is equivalent to the cube root of 2 cubed, which is equal to 2 to the 3/3 power, which is equal to 2 to the 1 power, and that is equal to 2. Okay, so here's a question for you, just as a side note. If, I'm going to write this in green here, if the square root of 2 times 2 is equal to 2, right, and I've taught my class, and hopefully your teachers have shown you this, if we have two numbers underneath this radical sign multiplied together, both of these can come out of the radical sign, and it works out to be just 2, and the radical sign disappears because there's nothing else left. So here's the question. Why is it that the square root of 2 times 2 is equal to 2, but the cube root of 2 times 2 times 2 is also equal to 2? Well, here's the answer. The key here is the root number. This root number tells you how many 2's, in this case, you're going to need in order to pull it out of the radical sign. So this root number says I need 3 of them, so I have 1, 2, 3, and this is why we end up with a 2 on the outside. In this example, right, the implied number here is 2. So this tells us that this 2 means that we need two of these, and we have 1, 2. Since we have 2 of those can come out of the radical sign and be represented as 1. Okay, so if this had been 5, this means that we would need 5 of these in order to pull them out. Otherwise, we couldn't. Okay, so hopefully that makes sense. Let's work on this example. Okay, so we're going to convert 9 to the 7/4 power to a radical number. All right, so then, as we know from the previous example, this is going to be the 4th root of 9 to the 7 power. Okay, 4th root of 9 to the 7 power. Now, this also, if we're going to simplify this, this is really the 4th root of 9 times 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 9. Okay? A total of 7 times. 1, 2, 3, 4, 5, 6, 7. I went too far. Okay, total of 7 times. Okay? Because this says 4th root, we need 4 of these. Okay, we need 1, 2, 3, 4. And we have 4 of those. So all 4 of those can come out and be represented as one number outside of the radical sign. And so the balance is going to be 4th root of these 3 remaining 9. So it's going to be 9 times 9 times 9, or 9 4th root of 9 cubed. Okay, so this becomes our answer. Okay, let's take a look at the following example. Okay, and I'm going to use this as sort of a ridiculous example where we have 7 to the 105 over 25 power. Okay, now I'm making this ridiculous because I want you to recognize that we're not going to write 7 times 7 105 times. Okay, so let's go ahead and convert this to a radical number. This is going to be the 25th root of 7 to the 105 power. Okay, so how do we break this down? Well, we need chunks of 25. Okay, chunks of 25. So this is really going to be the 25th root of 7 to the 25 power times 7 to the 25 power times 7 to the 25 power times 7 to the 25 power. Okay, so that gives us 25, 50, 75, 100. But we need 105. So we also need to multiply this by 7 to the 5th power. Okay, now when you separate this into chunks, it makes it easier to know how many 7s we need to pull out. We have 1, 2, 3, 4 chunks of 25, so that means 7 times 7 times 7 times 7 on the outside of the radical sign. Okay, 25th root of 7 to the 5th. And if you go ahead and simplify this, this is going to be 7 to the 4th power, because we have 1, 2, 3, 4 being multiplied together. 25th root of 7 to the 5th. Okay? Let's do one more example just to reinforce what I was just showing you in the previous example. So we've got 6 to the 37 over 5 power. Okay? This works out to the 5th root of 6 to the 37 power. Okay? That means that we can create several chunks of 6 to the 5th, and more specifically, 7 chunks. 5, 6, 7. Okay, now how do we know it's 7 chunks? Well, 5 goes into 37 7 times. Okay, so that's 1, 2, 3, 4, 5, 6, 7. 5, 10, 15, 20, 25, 30, 35. And we have a balance of 2 left. So that means this is going to be 6 to the 2nd power. And since we have 7 chunks, right? 7 chunks of these, 1, 2, 3, 4, 5, 6, 7. That means we have 7 chunks on the outside. 6 to the 7th power, 5th root of 6 squared. Okay, so hopefully you have a much better idea of how to take a radical number and transform it into a rational exponent, and then take a rational exponent and transform it to a radical number and simplify that number. So if any of this was confusing, please go back to the beginning of the recording and listen to this again. Thank you.